Well, as you can see from the title, this ShowMe is about factoring squares. Factoring, you'll recall, is multiplying backwards. So let's take a good look at what the multiplying looks like forwards before we try to do it backwards. In this picture, it's a representation of x plus a times x plus a. The idea is that we're finding the area of a rectangle, and the rectangle happens to be a square. So this would be x plus a squared. When we actually do the multiplication, it's just like doing the flow method. X has to be multiplied by both x and a, and then a has to be multiplied by both x and a, and then all those products have to be added together. And as usual, there will be a middle term that actually is a sum of two like terms. If you look at the rectangles that are created, the little regions in the picture, you see that the big square is represented as x squared, and then we have ax, not once, but twice. And then finally the last piece is a smaller square, as represented here, representing a squared. I want you to see this and understand this is the crucial key to recognizing when you are factoring a square. The hard part about factoring squares isn't the actual factoring. The factoring is simple. The hard part is knowing when you are dealing with a square polynomial and when you are not. So note here, when you are dealing with a square polynomial, if you write the expression as four terms, and you can write the central term, the middle term, as the sum of two identical terms, then you've got a square. That's what we'll be looking for as we work to identify when we can factor a square polynomial. Let's go to some examples to see what that looks like. This is a square polynomial, but let's pretend for a moment that we don't recognize it as such. The factoring procedure that I teach has us recognize that a is 1, b is 8, and c is 16. Our goal then is to discover all the numbers that are factors in pairs of AC and have a sum of B. Since AC is 16 and B is 8, we want to know what numbers multiply to 16 and also add to 8. And the answer to that is 4 and 4. If we were to keep going from here, we would be writing x squared plus 4x plus 4x plus 16. Then we'd factor by grouping. The first two terms have an x in common. The third and fourth terms have a 4 in common. And then we have two terms both featuring x plus 4. We factor out x plus 4. We have an x plus 4 left. And the result is x plus 4 squared. All of this was unnecessary. We shouldn't have done it. We don't have to do it. And I don't want you to do it anymore. Once we knew that we had two matching numbers that would accomplish what we desired, multiplying to 16 and adding to 8, at that moment we should know this is a square polynomial. If we haven't recognized it before, we know it now. What is being squared when we get x squared? Well, that'll be x. What's being squared when we get 16? 4. What is this? It's a plus sign. That expression factors to the quantity x plus 4 squared. And no more work need be done. Once you see this, you can revert to the sequence of steps I just showed you. Remember that this sign right here will not have any bearing on anything, because this number is a square, and all squares will be positive in this context. So I hope that helps. Let's take a look at a few more complicated ones before we wrap this up. Let's say that we don't immediately recognize this as a square polynomial. Our procedure begins by multiplying a and c, in this case 4 and 225, to get 900. The question we must answer now is, can we find a pair of factors of 900 that have a sum of 60? And we can. 30 and 30 fit that bill. Now that we see two matching numbers, we know we have a square polynomial. To get 4x squared, we squared 2x. To get 225, we squared 15. This sign is positive. The expression factors to 2x plus 15 squared. A lot of times students ask me, how are we going to get the middle term out of that? Well, it's not that hard. Do the FOIL method really quickly. 2x plus 15 times 2x plus 15. Let's see if we still get that 60 in the middle. First times first. 2x times 2x is 4x squared. Outside terms, 2x times 15 is 30x. Inside terms, 15 times 2x is also 30x. And last terms, 15 times 15 is 225. We will indeed get our 60. So there's no need to ask that question again. If you get matching numbers, when we answer that important question for factoring purposes, if the numbers match, then we've got a square polynomial. And all we have to do is match these numbers up and this sign, and we're done. We haven't yet looked at an example where we have a minus sign after the first square term. Let's take a look at one now and see if it really is that much of a challenge. Well, we're going to pretend we don't know that this is a square polynomial. So we start off calculating AC. We take 9 times 361. It's 3,249. B, of course, is negative 104. Can we find two numbers that have a product of 3,249 and a sum of negative 104? And yes, we can. Negative 57 and negative 57. So this is a square polynomial. We squared 3x to get 9x squared. We squared 19 to get 361. This is a minus sign, so this will be negative. And we started out with a square polynomial, and this is its factorization. This is a really important skill because we're going to have a lot of work to do with squares when we get to completing the square. The factoring itself won't be hard, but we have to come to a clear understanding of how to create the square polynomial. We have to be able to do this forward, backwards, inside out, and upside down. We need to become experts. I hope that helps. The key insight again is that if you're following my factoring procedure, whenever it happens that your two middle numbers are going to match, you've got a square polynomial, you don't have to do the big convoluted factoring process anymore. The process is pretty much over at that point. I hope that speeds up your work when you're factoring squares.